Okay, so this is our example problem. So we need to use JMP to generate ANOVA table. So how we can do that? So JMP, the input should be 2 columns. One column is just a type of box. That's the factors. Another column, that's the response variable, compression strength in this example. And then we need to copy the data. See, type the first row here. We could copy and paste here, right click and transpose. And this is type 1 box. And the second row, that's the type 2 box, right click. Some of the software can automatically stack the columns into 2 columns. But we, since the small size problem, we just manually do it. Right click. This is type 3. This is type 4. Transpose for data. Now we have 4 type of boxes, and the compression strength, we copy the data and paste it into JMP. We can generate a new table and paste with column name. See, type of box and the response is the compression strength. Now, first thing, make sure for the ANOVA analysis, the response should be continuous random variable. You see, this is a continuous random variable. And you click type of box. It default continuous because it's just numerical numbers. So here we just click ordinal. So that means this data, 1, 2, 3, 4, it just means group. It's not means the quantitative value. Okay? So make sure your input, the different levels, that's categorical type of data. Okay? In this case, we use ordinal. We analyze, fit model. So compression strength, that's our response. So we put Y. And type of box, that's the factor we put here. And then we run, we click run. See, so what are these about? We scroll down here, analysis variance. So we have the table here, analysis of variance. You right click, editor. You can copy picture. Then you can put it back. ANOVA table. So it gives you the calculation and also F ratio. This is the p-value. So if you look at what we manually calculate, see, this is we did it in class, manually calculate. It should be the same. Okay. See, the mean squared error is the same, F ratio is the same, and the probability is less than 0.001, very small. So that means at least one mean strength is different from other type of boxes. So analysis variance, we use JMP can generate the analysis variance ANOVA table, but it has 3 assumptions: constant variance, a residual. For this one, this graph shows residual by predicted plot. So this yeah, roughly the variance are the same. And here shows this is the plot, the probability plot. It's not that good, but roughly it's normal distribution. And you didn't see any patterns here. So that meets the 3 assumptions of ANOVA. So next thing is, since F ratio is large, the p-value is small, indicate at least one mean is different from others. How we can tell which one is different from others, or which two? So we use the pairwise comparison. So in other words, we compare each mean. We compare with each other. So if you click here, you will see one is the least square means student T. That's one type of test. If you click here, so it's compare mu1 versus 2, 3, 4, and mu2 versus 1, 3, 4. So after the comparison, it grouped the data into different groups. If the data in the same group, that means no difference. But you see C is different. The number 4 is in group C. So it's different from others, but it's hard to tell, like 1, 2, 3. We also can try another type popularly used called 2-key. If you click 2-key method. So this way is a little bit clear. Type 1 to 3 belong to the same group, just no difference on the mean strength, but type 4 belong to different group, and the mean strength is significant below. So that's the finish the whole process of ANOVA. If the ANOVA table tells you the p-value is large, there's no difference, we can't reject the null hypothesis, we stop there. If there is difference, and then we can run this pairwise comparison and to find out which mean is different from others.